Overview of machine learning and pattern recognition. Patterns are an integral part of our everyday lives, influencing everything from the clothes we choose to the technologies we interact with. Machine learning operates on a similar principle, but at a much larger and faster scale. In this video, we will delve into the concept of pattern recognition and discuss its vital role in the field of machine learning. How machine learning works. Machine learning, ML, is a field of artificial intelligence that enables computers to learn from data and make decisions without explicit programming. The process of training an ML model can be broken down into three main stages: understanding patterns, measuring error, and optimization. Let's explore each part in more detail. Stage 1. The decision process. Machine learning models are designed to recognize patterns in data and use these patterns to make predictions. But how does a model make these predictions? The basic process involves finding patterns in input data, whether it is labeled or unlabeled, and then using these patterns to derive results. For example, when training a model to predict whether an email is spam, the model analyzes examples of labeled emails, spam and not spam. As it examines these examples, the model learns to identify distinguishing features and apply them to classify new, unseen emails. The more examples the model processes, the better it becomes at recognizing the underlying patterns. Stage 2. The error function. Once a prediction is made, the next step is to compare it with the actual result, also known as the ground truth. The error function, or loss function, helps the model determine how far its prediction is from the correct answer. This step is essential because the model needs feedback to know if it's learning correctly. A large discrepancy between the prediction and the ground truth means the model needs to adjust its parameters. The ultimate goal is to minimize this error and achieve higher accuracy in predictions. Stage 3. The model optimization process. The goal of machine learning is to improve the model's predictions by reducing the error between its predictions and the actual outcomes. This process involves optimizing the model's parameters, or weights, so that the model better fits the training data. Machine learning algorithms use methods like gradient descent to optimize the model. In this process, the model makes adjustments to the weights based on the error calculated in the previous step. The optimization process is repeated multiple times, each time refining the model to improve its predictions. In real-world applications, machine learning models do not stop improving after initial training. They continue to learn as they are exposed to new data. This ongoing learning allows the model to adapt to changes in the data and refine its predictions over time. In conclusion, machine learning involves recognizing patterns, measuring error, and optimizing the model's parameters to improve predictions. Through this iterative process, the model learns from data and becomes increasingly accurate over time. Key elements of machine learning algorithms. Machine learning encompasses thousands of algorithms, which can be categorized based on their learning style or the specific problem they are designed to solve. However, all machine learning algorithms share several fundamental components. 1. Training data. Training data refers to the input information such as text, images, videos, or time series data that a machine learning system learns from. Typically, this data is labeled to guide the system toward the correct output. For example, in a face detection task, training data might include images with bounding boxes around faces, or in a stock prediction model, the data might include past stock performance to predict future trends. 2. Representation. Representation involves the encoded forms of objects within the training data. A face might be represented by features like eyes or nose. The ease of encoding different models influences the choice of algorithm. Neural networks, for example, use one form of representation, while support vector machines use another. Modern approaches often favor neural networks due to their effectiveness in capturing complex patterns. 3. Evaluation. Evaluation is the process of assessing and comparing the performance of different models. It often involves utility functions, loss functions, or scoring functions. Common evaluation metrics include mean squared error, which compares a model's output with actual data, or likelihood, which measures the probability of a model given the observed data. These functions help determine which model best fits the task at hand. 4. Optimization. Optimization is the method of improving model performance by searching through possible representations or adjusting training data labels. It involves tweaking model parameters to minimize the value of the loss function, thereby enhancing the model's accuracy over time. Effective optimization speeds up the learning process and helps refine the model's predictions. These key elements form the foundation of any machine learning algorithm, guiding the system toward more accurate and efficient learning. What is pattern recognition? Pattern recognition refers to the process of detecting, interpreting, and classifying recurring structures or trends within data. This is often achieved through the use of algorithms and mathematical models. In the context of machine learning, ML, pattern recognition involves training computers to identify and comprehend patterns in diverse formats. These systems can independently make predictions, categorize information, or make decisions based on the identified patterns. Let's break down the key components of the pattern recognition process. Finding patterns in data. 1. Data acquisition and preprocessing. Pattern recognition systems can process various types of data, such as text, video, or audio. The first step involves acquiring and preprocessing this data. During preprocessing, the system performs tasks like data augmentation and noise filtering to enhance the quality of the input. 2. Data representation. Once the data is filtered, a neural network analyzes it to uncover meaningful information. This stage involves extracting and segmenting features, which are then organized into recognizable patterns. 3. Decision-making. After identifying patterns, the system uses these insights to make predictions. Depending on the business case, the system can perform class prediction, categorizing data into predefined labels, using labeled datasets. Cluster prediction, grouping data based on similarities, using unlabeled datasets. Value prediction, estimating continuous values, typically through regression analysis. This structured approach enables the system to derive actionable insights and address specific objectives. Stages of pattern recognition. Pattern recognition, a key branch of machine learning, focuses on identifying and categorizing data patterns. It can be broadly divided into 2 stages. 1. Explorative pattern recognition. This stage focuses on uncovering general patterns within data. Algorithms in this phase search for hidden patterns or clusters of features, often using unsupervised classification. Here, input patterns are grouped into undefined classes based on their similarities without prior labels or predefined categories. 2. Descriptive pattern recognition. In this stage, the goal is to classify detected patterns into predefined categories. It relies on supervised classification, where the system uses labeled data to identify and categorize patterns as part of known classes. Pattern recognition typically involves tasks of classification or categorization. Depending on the approach, the classes are either predefined and labeled, supervised classification, or learned dynamically by analyzing similarities between patterns, unsupervised classification. Pattern recognition and machine learning techniques. Machine learning and pattern recognition work together to enhance systems' abilities to make decisions, learn from past experiences, and predict future outcomes. These techniques demonstrate how machine learning and pattern recognition empower systems to analyze data intelligently, adapt dynamically, and make informed decisions across various industries. 1. Statistical pattern recognition. Statistical pattern recognition analyzes data based on numerical and probabilistic models. In a business context, this method can be applied to customer purchase history. By learning from past purchasing patterns, systems can predict future buying trends. For example, a supermarket chain might use this approach to identify products that are often bought together, enabling them to design targeted promotions during checkout to boost sales. 2. Syntactic pattern recognition. Syntactic pattern recognition focuses on identifying structural relationships within data. For instance, a publishing company could use this method to analyze and categorize written content. By assessing words and phrases, primitives, for their structural arrangements, the system can recognize writing styles, genres, or intended audiences. This enables the effective organization and categorization of content for different reader segments. 3. Neural pattern recognition. Neural pattern recognition uses artificial neural networks to detect complex and nonlinear patterns within data. For example, a financial institution might utilize this method to identify fraudulent credit card transactions. Neural networks analyze relationships between spending behaviors and potential fraud indicators. By processing large volumes of transactions in real time, the system learns to identify subtle patterns associated with fraudulent activity and flag suspicious transactions for further review. Over time, it becomes more accurate through continuous learning. Machines can emulate the pattern recognition capabilities of the human brain, but at a much greater scale and speed. The integration of these approaches significantly enhances a system's analytical capacity, leading to 3 primary methods. Pattern recognition and machine learning applications. In today's fast-paced business environment, the integration of pattern recognition and machine learning (ML) has emerged as a critical tool for driving efficiency and unlocking strategic insights across multiple industries. These technologies enable businesses to analyze vast amounts of data, recognize patterns, and automate processes, leading to optimized decision-making and innovation. This video will highlight some notable applications of ML-powered pattern recognition across different sectors. These applications are: 1. Visual recognition for retail and marketing. Pattern recognition plays a pivotal role in retail and marketing by enabling businesses to identify products within images. This functionality allows for automated inventory management and real-time tracking of customer behavior. Machine learning models can analyze visual patterns from consumer interactions, providing valuable insights that can shape personalized shopping experiences. Facial recognition technology further elevates this by offering tailored recommendations and targeted marketing strategies based on individual preferences and demographics. 2. Traffic flow optimization in smart cities. Smart cities are increasingly utilizing pattern recognition to optimize traffic flow and reduce congestion. Analyzing vehicular movement patterns through sensors and cameras, municipalities can adjust traffic light timings and manage transportation networks more efficiently. This not only benefits urban commuters but also has profound implications for businesses in delivery and logistics, as optimized traffic flow can lead to improved route planning and reduced delivery times. 3. Voice and language processing for customer service. Voice recognition technologies powered by machine learning have revolutionized customer service by enabling real-time assistance through virtual assistants. These systems can process spoken language, identify patterns in customer queries, and provide tailored responses. As a result, businesses are able to streamline operations, reduce response times, and improve customer engagement. Moreover, these systems can operate 24/7, providing customers with consistent, high-quality service. 4. Biometric security for access control. Biometric authentication, which relies on pattern recognition to identify physical characteristics such as fingerprints, facial features, or retina scans, is gaining ground in corporate security. These systems are widely used for secure access to buildings, devices, and sensitive data. By reducing the risk of unauthorized access, businesses can safeguard critical assets and mitigate potential security threats. 5. Geospatial analysis for resource management. In industries like agriculture, mining, and natural resource management, pattern recognition is used to analyze geospatial data. Recognizing patterns in geological, environmental, or crop data, companies can make more informed decisions about resource allocation, optimize yields, and enhance sustainability. Efforts. This technology also helps predict environmental changes and manage risks associated with resource extraction. 6. Medical imaging and healthcare management. In healthcare, machine learning-based pattern recognition is extensively applied in diagnostic imaging. Studying images such as X-rays, MRIs, and CT scans, ML models can detect early signs of anomalies, such as tumors or fractures, that may be overlooked by human doctors. This capability enables proactive healthcare management, faster diagnosis, and more personalized treatment plans, ultimately improving patient outcomes. 7. Speech recognition for accessibility and efficiency. Speech recognition systems have gained traction in business operations, offering hands-free control over devices and improving accessibility for people with disabilities. From dictation software to voice-controlled smart devices, these systems enhance operational efficiency by enabling multitasking and reducing the need for manual input. This also allows for improved inclusivity, as individuals with physical disabilities can interact with technology more easily. 8. Financial forecasting and risk management. In the financial sector, pattern recognition and machine learning play an instrumental role in analyzing vast amounts of market data to identify trends, forecast stock performance, and assess risks. Financial institutions use these insights to make data-driven investment decisions, minimize potential losses, and enhance the overall risk management process. This predictive capability allows businesses to stay competitive in a constantly changing market environment. The growing prevalence of pattern recognition and machine learning across various sectors demonstrates the immense potential of these technologies to optimize operations, enhance customer experiences, and drive innovation. As businesses continue to harness the power of data, the future of ML applications will no doubt open up new opportunities for smarter decision-making and sustained growth. If you have enjoyed this video, don't forget to visit our online educational platform at www.eduslides.com by registering for free courses. Guess what? You can as well earn a certificate of completion after completing your course, and you don't have to pay to register. Why not subscribe to our YouTube channel to get more videos by clicking the subscribe button below?